So we've been talking about telescopes, and basically the telescope is the tool that astronomers use to measure light. But we know that there's more than one kind of light. We've been talking about visual telescopes because that was the beginning of telescopes. Galileo Galilei, finding out how telescopes work, pointing a telescope up into the sky, saw things. Saw sunspots, saw stars that you could not see with the naked eye, saw little fuzzy patches in the sky. So this was our first tool. Use your eye, look in the sky. Second, photography. So now you have the idea that you can take a picture of it. So it's not just the subjective, hey, this is what I saw. Third, use other instruments. Measure brightness, that's a photometer, or you can also use spectrometer to measure the spectroscopy of something. So there's several different other, measure spectral characteristics, so there's several other tools you can use. So there's many different tools that are visible, that are usable with visible light. But visible light is not the only part of the electromagnetic spectrum that astronomers would want to look at. Now, some years ago, right before class, I was checking the National Weather Service radar. I typically do this before my evening classes to figure out kind of what's the possibility of the weather and so forth. So this was the radar image of that night. This was actually some years ago. So this was 2005, and this is what the National Weather Service radar looked like in 2005. The date was, the date here was February 22nd. Or 25th, 2005, and the time was 0:14 Universal Time. Okay, now you remember from our time conversion exercises in previous lectures, what does 0:14 mean? Well, this is February, so this is 6 hours difference because we're on standard time. So you subtract 6 hours from 0:14, that'll be 6:14 p.m. So 6:14 p.m. on February 25th, the National Weather Service radar had this giant spike in the west-southwest. Now the modern radars don't do the spike as much because they are computerized to take the spike out of the data, but the spike is really still there in the raw data. 2005, they did not have the computer-enhanced radar. So they just recorded what they saw, recorded what it saw. And there was this big spike out there. Now that spike, you know, you might originally expect to be ground clutter, except the spike was not there about 15 minutes earlier. It was not there 15 minutes later. It was only there for a very short amount of time. So something right close to the horizon in the west-southwest at 6:14 p.m. on February 25th. So what was that? Well, that's the sun. So National Weather Service radar was picking up the sun. Well, obviously it wasn't bouncing off the sun. I mean, the sun's too far away. The radar couldn't do that. But it means that the sun was giving off the same wavelengths of microwaves that the radar was using to monitor weather. And so that was an interference. The same thing happens sometimes at certain times of the year when the sun lines up right behind geosynchronous satellites, overwhelms the signals from the satellites. The sun gives off a lot of radio waves, gives off microwaves, gives off ultraviolet light, gives off X-rays, gives off all kinds of different wavelengths, not just visual light. So this raises the question, can we use other wavelengths of light to monitor celestial objects? This gives rise to the idea of radio telescopes, which your book talks about in Chapter 6. The very first radio telescope was actually purely accidental. A fellow named Karl Jansky was studying the possibility of radio communications. He worked at Bell Labs. Now, this is not the Bell helicopters, this is Alexander Graham Bell. So Bell Labs did telecommunications, and he was looking at the possibility of using radio waves to transmit voice communication. And this was a revolutionary idea in the 1930s. One of the problems they had was that long-distance wires, long-distance telephone calls used wires. And that means that for everybody speaking, long distance, there had to be a separate wire carrying that conversation. And so that made obviously very, very expensive long-distance phone calls. And you could only have so many people talking at one time. So you could only have a few dozen people at one time talking between the DFW area and the Houston area. And so the cost would be very, very high. People typically did not make long-distance phone calls because they were so expensive, and they charged you per minute. So it would be like you'd try to keep it very, very short. And so his idea was maybe we could get more phone calls if we carried the voice over radio waves. And so he built this large rotating radio dish and discovered that there was static that kept repeating in his experiment. The static actually came about repeated every day at about the same time. Over a few weeks of studies, he began to realize it wasn't exactly the same time. It was about 4 minutes earlier every day, so every 23 hours, 56 minutes. And he quickly realized that's a sidereal day. He was actually picking up static from outer space. And so that was a huge discovery right there, that he was picking up static from deep space. And he traced a couple of these things. For example, some of the static repeated every time Jupiter rose, and some other static repeated every time the center of the galaxy rose. And so when Jupiter's above the horizon, you got static. When the center of the galaxy is above the horizon, you got static. And so that meant that something at those places was giving off radio signals. And so he published a paper suggesting that you could actually do radio astronomy. Now, two things happened here. First of all, his employers said, well, this is not doing anything to bring us in money. You were hired to bring us in money, so you have to quit working on the science stuff and go back to engineering communications. Second thing that happened was he got the Nobel Prize. And so Jansky started the science of radio astronomy, but he was not able to pursue it. It was actually followed by an electrical engineer working at University of Chicago. And he built this large dish, and the idea was the radio signals from space would hit the dish and bounce up to a receiver that was suspended at the apex of the dish. And so this became the first operating dedicated radio telescope. With this, he scanned the sky looking for various signals. Now, this was in the 1930s. He built this, and late 30s, and this was all about the time World War II was starting in Europe. And so rumor got started that Professor Reber at the university had a contract with the Army to build some sort of anti-aircraft death ray. Because there was no such thing as satellite dishes, so no one had ever seen a big shape like this in the sky other than in Buck Rogers movies. And so, but this was the first dedicated radio telescope.